Welcome to our lesson on generating electricity. Let's go right into the process. So almost all ways of generating electricity require that something is used to turn a turbine, which is basically, it looks like a airplane propeller, and that's connected to a generator, which is going to produce the electricity. So this is talking about making alternating current like we have in our homes. You're going to have a handout given to you hopefully in class today that will be used with this video. So when we get to the drawings, just refer to that handout. First, we're going to talk about hydroelectric. Hydroelectric uses the energy of moving water from rivers, or if we don't have a river with enough difference in elevation, we will build a dam blocking a river. That allows for water to back up so there's enough water to use. So the Niagara River was the first one locally meaning within the closest about 400 kilometers, where this was done because there's a pretty good elevation drop at the falls. The advantages of hydroelectric are that it's got a renewable quote-unquote fuel, meaning that as long as we have the water cycle going, we're going to have rain falling upstream, and so we don't have to really work very hard to get the fuel in certain places. There's really minimal air quality issues related to this because we're not burning a fuel. So it's just literally the production of the materials used to generate the electricity, and that's kind of a one-time thing. Disadvantages. In the event that you have to build a dam to produce a reservoir of water, that's going to damage existing habitat. So it's going to flood a certain amount of land, so it's going to destroy a certain amount of habitat that's upstream from wherever the dam is built. And any animals moving up or downstream, it creates a problem. So in British Columbia, where they did this, they had to build what are called salmon ladders, which are these fairly short-stepped canals that allow the salmon to go around the dam in order to make it upstream for spawning. We're going to move on in 3, 2, 1. Oh, sorry, my mistake. Diagram on the cross section so you can see the water behind the dam at the top flowing down to go turn the turbine to turn the generator. Okay, now we're moving on. Next, we're going to talk about steam turbines. So steam turbines use typically a fossil fuel, coal, oil, or gas to burn in order to boil water, which makes high pressure steam. Now, most time we use fossil fuels. There are a few places where we actually use incinerators for garbage. So we'll burn garbage, which can be used for this purpose. But that's a pretty small niche market. We probably could do a much better job in that area. Advantage, they are easily adjusted to produce the amount of electricity we want. So generally speaking, what will happen is when we need more electrical power, we turn more of these power plants on and they can produce power very, very quickly. And then when we've got too much, we can turn them off. The steam that's produced, you need a certain pressure of that steam to turn the turbine. And after it's done what it can for turning the turbine, we have what is called waste heat. And this steam can be used again so you can send it back to the boiler to make more steam to turn the turbine again. As well, the waste heat can be used to heat nearby buildings. So if you need to cool that steam more, you can send that heat off to nearby buildings, use it to heat the buildings in the winter. This is referred to as cogen or cogeneration. So you're able to produce electricity as well as heat at the same time. The disadvantage of this is you have a non-renewable fossil fuel being burned in the vast majority of cases, and those combustion gases are air pollutants that promote global warming. And here's again a cross-sectional diagram showing on the left-hand side the boiler section producing the steam to turn the turbine, and after it's done that, we've oversimplified the condenser so that you cool the steam back down to water so it can go in the boiler again. All right, moving on in 3, 2, 1. Nuclear. All right, so we mine uranium out of the ground, and uranium atoms break apart at a particular rate in a process called fission, and that releases a massive amount of energy. So for the same mass of fuel, when we compare one of those fossil fuels to uranium, the uranium per gram will produce about 100 million times more energy. 100 million, so 1 followed by 8 zeros. So that's a massive amount more energy compared to the fossil fuel. So they're pretty desirable that way. The advantage is you produce a great deal of energy with very little fuel. The bad thing about this is the radioactive waste that's left over is going to be dangerous for thousands of years, so we need a way to store this, keep it out of terrorist hands, that kind of thing. As well, there's always a risk that there's going to be some accidental release of radioactive materials, and in this part of Canada, we are in the downwind area of the Fermi nuclear plant in Monroe, Michigan. And so we have to be aware of some of the training exercises they do and some of the fallout plans that they have. Moving on to the last slide in 3, 2, 1. Oh, sorry, my mistake. The uranium atoms are packed into those little nuclear fuel pellets that are shown right there. And the pellets are put into a rod. Rod's put into a fuel assembly, and the top just shows that a neutron hits a uranium atom and it releases a couple of other elements, some heat and some more neutrons, and on we go. Sorry about that. All right, so last slide. Last couple ways of producing electricity, which are becoming more and more common. You've probably seen these around. Solar uses a photovoltaic or PV cell, which we use to make direct current using electricity or DC electricity from light, which we will, if we're using it in your calculator, we're just going to use the energy directly as DC. But if we're going to use this for our energy grid, we then convert it to alternating current. Advantages of solar: it's really clean, it's really quiet. So yes, you have some environmental problems with the production of the cells, but once they're made, they typically work for about 20 years or more. Disadvantage: they are pretty expensive to make. Obviously, it has to be sunny, and you need space to spread a bunch of these out because they don't make a massive amount of energy at any one time. And this is a diagram showing a little bit of what one of those photovoltaic cells looks like. You've simply got several layers in there, and because of the way they position different materials and sunlight hitting them, they can force electrons to move out of certain materials into other parts. All right, the last piece is wind, and you've probably seen solar panel or wind turbines around. So obviously they use wind energy to spin the generator directly, so there's no turbine involved. I should have mentioned in solar, obviously there's no turbine or generator because it's producing the electric current directly. Advantages: again, there's no air pollution, there's no fuel except in the production of making the wind turbines themselves. Disadvantage: they need a moderate wind speed because if the wind isn't blowing, they can't produce electricity. If it's blowing too fast, they can't make them spin too fast because they could actually break. So they're set up so that if the wind starts blowing too fast, they actually turn the blades to the point where the wind will just blow past them without turning the propeller. So that's a safety feature, and obviously they need a certain amount of space in between them in order to work properly. And you've obviously seen a bunch of these around if you've been around the area. All right, that's the last way of producing electricity. There are a few other minor ones, but we're going to focus on the biggies. These last two are ones that are becoming more and more popular, and nuclear is becoming more popular because of the lack of a greenhouse gas product. And of course, we pretty much used all the good rivers for hydroelectric, and I think we're going to hold it there. Thanks for watching.